Hi folks, I wanted to make a short introduction video to the circuit simulation that you'll be using for the lab exam. When you follow the link on the lab exam to the circuit simulation, the default settings on the simulation are a little different than what you might be used to in your regular circuit diagram. So when you click on the link and it takes you to the simulation page, be sure that you have clicked on the lab tab. Let me see if I can show you what it looks like. So this is probably the page you might find when you find the circuit construction kit. When you hit play to start the simulation, you're given a choice of just doing intro or doing lab. Click on lab because it gives you the ammeter that we want you to use. So you click on lab and you are met with a blank canvas with which to make your circuit. I find that this is, let's go ahead and recreate circuit circuit B, excuse me, with the 3 resistors in parallel. I find it a very intuitive interface. You see, all I'm doing is I'm dragging circuit elements, so you can have batteries, you can have light bulbs. We're just going to have a battery and actual resistances from the ceramic resistors here. If there's anything you wish to remove, you can click it. You see it's highlighted by yellow, and then you can delete it. So I'm going to delete this extra battery. And wires are free in the sense that you can use as many wires as you want. I'm going to make a circuit that pretty much looks identical to a circuit diagram. You can use a different number of wires to make a slightly different looking circuit. You see, all I'm doing is I'm dragging wires and making them look as though they are the black lines on our circuit diagram. Every time I want a new wire, I just drag it, and I can move these points. You can just grab a point, right, stretch it out, make it do whatever you want. We need 3 resistances here in parallel. Whoops. Sometimes you do need to be careful about the way that they snap together. The circuit that you make does not need to look exactly the same as the one I am making here. Well, this might be interesting to try to get that last resistor in there. Let's see if we can do it. Okay, good. But it should electrically be the same, even if it doesn't artistically look the same. So just a few more wires. I probably could have paused the video, but too late to do that now. Just a few more wires, bear with me, and we'll have a circuit that looks just like circuit B in our diagram. Now this is again what it would have looked like in lab instead of these gigantic ceramic resistors. We would have had in the place of those little tan cylinders, those black boxes with the green plugs and all the little switches that we switch up and down to make into whatever resistance we wish to use. Now, what we need to do in order to have this be able to make the measurements that we want, first we need to specify certain values for our batteries and our resistances. In order to do that, you can click on the resistance to change the resistance. You can click on the battery to change the voltage. So we wanted a 9-volt battery. It comes out as a 9-volt battery, but we could easily make it a 48-volt battery or a 23-volt battery or whatever the case is. Let's set it to 12 volts just for fun. I don't really remember what we used in lab. You see it goes up and down by half volts if you use the arrows. We'll set it 12 volts. Who knows? I'm not looking at the lab diagram, so I don't really remember. I do think this first resistance was 15. Whatever it is, you click on the resistance and you can change the value. Now, here we have cute little electrons running around these wires. That helps conceptually to understand what's going on. We need to actually make measurements. So up here in the upper right-hand corner, you have some options of what to see. You can unclick show the current. You can show conventional current. Electrons traveling the other direction of conventional current. For the case of the lab, once it is connected, and if you want to verify that current's running, that's great. I would go ahead and turn off show current since we don't need to see it. Now, to measure the voltage across these resistors or anything in our circuit, all you need to do is drag the voltmeter out of the little box there on the right. You see all I did was I clicked on it and dragged it out. I can put it away the same way. I can click on it and drag it out. And then we see the little black and red wires, just like we had in lab. If I want to measure the voltage across this resistor, let's say, I could put the voltmeter leads there, and there's the voltage there. If I want to measure it over the battery, I get the 9 volts over the 12 volts over the battery. Negative because of the way that I've connected the leads. So you can see I can switch red and black, and I get that. This can be in any position. The wires you see stretch out. So however it doesn't confuse you, that would be best. The diagram on before we do the ammeter and the current measurement, the diagram on the test and the diagram we've seen in the textbooks, just use our circuit symbols. Over here on the bottom right hand corner of the simulation, you can click on the little battery symbol, and you see that now we've got the same exact circuit, but instead of the cartoon, we've replaced it with our circuit diagrams. Another helpful thing to turn on would be the values of the resistances. So we can see here that I think we're supposed to have our friends 33 and 55, just like in lab. Now I think this is very close to what the actual lab circuit was. 3355, and this should have been 10. But anyway, that's not important. The circuit that you have will be different in terms of different values for the resistances. You can just look at the exam and put in those values. Now, one important thing I want to be sure that we know how to do is how to measure the current using this ammeter. This is the ammeter that we want you to use for the lab exam because it replicates the connections that needed to be made like we did in lab with the actual ammeter. This ammeter here with the little target reticle is a cheater. This is not a real ammeter. This is a fake ammeter that exploits the fact that this is a computer simulation and it's all fake to begin with. But the lab exam wants to test your lab skills, and one of those things was how we connect an ammeter to measure current. The reminder I'm going to give you is that the ammeter must be installed in series. The voltmeter, when I'm wiggling around on the screen now, is in parallel. So all I need to do is touch my 2 leads, right? Just like we had in lab, I don't need to change anything about how I don't need to change anything about my circuit when I measure the voltage with the voltmeter. I am adding it in parallel. I don't need to unplug anything or plug anything back in. That is not the case with the ammeter. Let's move the voltmeter off to the side. With the ammeter, I need to disconnect part of my circuit and install the ammeter in its place. How do I disconnect something? Well, on the simulation, let's say I want to measure the current through, let's do this 15 ohm resistor. I want to measure the current into this. So I need my ammeter to basically take the place of this little wire between this point and this point. You see when I touch a junction of 2 wires on the simulation, I get the option to cut it open. So I can do that twice, and I can remove, I can remove this piece of wire. There we go. It doesn't want to do it. There we go. I can remove this piece of wire, and then I can put my ammeter in its place, and we see that now I'm measuring the current through what was that section of wire into this first resistance. To remove the ammeter again, one thing we could do is we could just trash it and then pull a new ammeter out, or we could again cut the ammeter out of the circuit using clicking on the little junctions there, and then I can put the wire back. The circuit diagram wires are a little harder to handle than the cartoon wires, but now the current is running through my circuit again, and I can see that those little charges are moving. That's a good way to check. Just wanted to make this quick little video about how to use this simulation in case you don't feel like playing around with it. I think a lot of this is really intuitive. Feel free to explore, and worst thing is that you can always hit this little orange button and start all over from scratch and make a brand new circuit. The screenshots that I want are of your complete circuit and specifically showing your 2 meters, your voltmeter and your ammeter, while you're measuring the current and the voltage across the 55, sorry, not 55, what's in the play, the 36 or whatever ohm, I think it's R4, the 36 ohm resistance. So I do want screenshots of those two circuits, of your circuit and of your circuit with the meters in it, but only for measuring the current and voltage through R4. If you have any questions about this while you're doing your lab exam, feel free to reach out to me and I'll get it figured out for you.